Hi, in this video we're going to work the first page from the worksheet 5.6. This is the growth and decay formula we're going to be using for this particular assignment. It actually does change into the PERT formula with money later on throughout this assignment. But right up in the exponent you have K and you have T. K is your rate, and K can be positive or negative depending on whether you are growing or you are decaying. Is your rate going up or is it going down? You can pause the video if you need to read what each of these variables stand for in the equation. I'm going to pull this down and we're going to start with example number 1. It says a certain strain of bacteria grows from 40 to 326 in 20 minutes. The formula is above. Find K for this strain of bacteria. Alright, so I'm going to go ahead and write the formula down, which is A of T is equal A sub 0 times E raised to the KT. Now, in this particular problem, K is going to be a positive number when we're done because we are growing. We're going from 40 to 326, so this is going to be a growth. Since you're starting at 40, that would be your beginning, your initial term, which is A sub 0, and you're going to end at 326, which is the Y value, which is A of T. So we're going to say 326 is equal to 40 times E raised to the K. Now, to go from 40 bacteria to 326, that happens in 120 minutes. So that means that T up here is going to be 120 minutes. Now, we're going to go ahead and solve this equation. The base is E, the exponent is 120K. Since the 40 is not part of the base or the exponent, I'm going to change colors here, and I'm going to divide by 40 on the right side, and I'm going to divide by 40 on the left side. When I divide these two on the left side, I end up with 8.15 is equal to, the 40s cancel over here, and it's equal to E raised to the 120K. Now we're looking for K, and it's up in the exponent. And since there's an E in the problem, we're going to take the natural log of both sides. So we're going to take the natural log of 8.15, and we're going to set that equal to the natural log of E to the 120K. Now, the one reason we're using natural log, because there's an E here, is because natural log also has a base of E. And you have a property that says if these bases match, okay, if these bases match, then the answer to this natural log is 120K. It's the exponent. It's whatever is up there left in the exponent area. So we're going to say this is the natural log of 8.15, and that is equal to 120K. That's using one of your property rules. As if the bases match, the answer is up here in the exponent. So to get K by itself, I'll go ahead and change colors one more time. I'm going to go ahead and divide both sides. Sorry, that was our school bell. I'm going to divide both sides by 120. And when that gets divided and it's put into the calculator, K ends up being, it says round to 2 decimal places, K ends up being 0.02. Now, and that is the answer, okay, to the first part. I want to make sure you know when you put it into the calculator, you do have to, it's going to open a parenthesis after you press natural log here. You have to close the parenthesis here before you hit divide. Otherwise, it's going to treat all of this as the argument. It's only the 8.15. That's the argument. Now we go down to part B. And it says, write the growth equation for this strain of bacteria. If we're going to write the growth equation, and the growth equation is going to tell us how many bacteria we're going to end up with. Okay, this is how much bacteria we're going to end up with. Like up here we ended with 326. You need a starting value, which in this case is 40, and you're going to set times that by E raised to the rate, which in this case we found it to be 0.02 from right up here. That was K, and we're going to multiply that by the time. So if I'm given a time, I can then find the answer for the number of bacteria that will be present at that certain time. And that problem is complete. I'll move this down just a little bit. Now we have part C. It says find the number of bacteria after 3 hours. Okay, well that means you're going to let T be 3 hours, which in this case is equivalent to 180 minutes. Now we're going to be using the 180 minutes because back up here in the original problem, in the original part, it gave us 120 minutes. And we used minutes to create this K value. This K value, which is 0.02, only works in minutes. So therefore, I have to use the 180 to solve this problem. So let's see what we have here. If I'm going to let all the T's, oh, wrote in 3, that's not good. All the T's be 180. That means that you're going to be doing 40 times E raised to the 0.02 times 180. Now, remember this is just function notation, so this just says let T be 180. That's all this is. I'm really looking for this side of the equation, okay? And I have everything over here. I know the 40. I know how to put E into the calculator. I know 0.02. I know 180. I'm just going to take 40 times E raised to the 0.02 times 180. It's all in one step in your calculator. You start at the 40 and you work your way over, and that answer turns out to be about 1,463.93 when you put it in the calculator. And this is bacteria. So our bacteria has increased from 40 to 1,463 in 3 hours. And that completes part C. Now we have part D. And part D says, when will there be 1,000 bacteria? Well, if you're going to ask when there's going to be 1,000, well, 1,000 is this side of the equation. That's our answer to the whole thing. That's how many bacteria you're going to have. Of course, I'm writing an 8 there. Let's try that one more time. 1,000 is equal to, the beginning was 40, E, the rate is 0.02, and we want to know how long. When, that's the question, when. You're going to search for T. So we're going to do exactly what we did in part A, except now we're not looking for K, we're looking for T. So I'm going to go ahead and divide both sides by 40 again. When you divide by 40, you get 25. The right side, the 40s cancel, and you get E raised to the 0.02 T. We're going to go ahead and take the natural log of both sides. And I'm going to change colors here again, remind you that the natural log has a base of E, and since these guys match, the answer is 0.02 T on the right side. So the natural log of 25 is equal to 0.02 T. And to get T by itself, I'll just come over here. To get T by itself, we're going to have to divide off the 0.02. So we're going to take that natural log of 25, and we're going to divide by 0.02. And T turns out to be approximately 160.94 minutes. And you do have to label your answers. I'm going to go ahead and box this to show this is my final answer to the question. That does complete the first page. Now, there are some slight changes, some slight variances in this particular assignment. But, I mean, it's pretty close to being the same. You're going to do this process for most of the problems in this particular worksheet. The only difference is when I look over at number 6, you start to change into money, which means it's the PERT problem. But I want you to know that the PERT problem is the same as this. I mean, normally I have A equals P E to the RT. It's the same question pretty much. It's just using slightly different letters to answer the problem. So good luck with it. If any questions, I'm here after school on Thursdays.